This is the phenomenon that even Albert Einstein never fully understood before his death: ball lightning. It doesn't need a thunderstorm to appear. It can emerge seemingly out of nowhere. Scientists have studied it for nearly 2 centuries, yet no one can definitively explain why it exists. Witnesses claim it can pass through windows, slip through door cracks, travel down chimneys, and in some cases even move directly through walls. According to everything we know about physics, a glowing object with physical volume should not be able to pass through solid matter. And yet, hundreds of eyewitnesses around the world insist that it does. Even stranger, although it emits light, it isn't always hot. Some people describe intense heat. Others claim they stood only inches away and felt nothing but cool air. A bizarre way to disappear. The way ball lightning disappears may be even more mysterious than the way it appears. Sometimes it simply vanishes, as if someone flipped a switch. Other times, it explodes violently, leaving behind the smell of ozone, scorched surfaces, and even damaged walls. What troubles scientists most is that ball lightning does not appear exclusively during thunderstorms. People have reported seeing it on clear sunny days. Others have encountered it during winter nights with temperatures below -20 degrees Celsius. It has been reported in windowless basements, inside sealed submarines, even in aircraft cockpits cruising 10 kilometers above the Earth. If ball lightning is merely a product of ordinary lightning, why can it survive after the lightning itself is gone? And if it is simply a form of plasma, why doesn't it dissipate almost instantly like every other plasma found in nature? A mystery spanning 2,000 years. Humanity has been asking these questions for centuries. Some of the earliest accounts date back more than 2,000 years to ancient Rome. The philosopher Seneca described glowing spheres appearing during thunderstorms. Medieval European chronicles contain countless reports of what people called devil's fire entering homes through chimneys. But the event that truly cemented ball lightning in historical records occurred in Devon, England in 1638. During a church service, a glowing sphere suddenly burst through a window. It flew down the center aisle and exploded against a wall. 4 people were killed instantly. Chunks of stone fell from the ceiling, and the church filled with a strong, sulfur-like odor. The incident was recorded in church archives, and many locals believe they had witnessed the arrival of a demonic force. The first scientist killed by ball lightning. More than a century later, in 1753, Russian physicist George Wilhelm Richman was conducting atmospheric electricity experiments. During a thunderstorm, while observing a lightning attraction apparatus, a blue glowing sphere suddenly emerged from the equipment. It struck him directly in the forehead. He died instantly. His assistant was thrown across the room and suffered severe burns. Richman became the first scientifically documented fatality associated with ball lightning. His friend, the renowned scientist Mikhail Lomonosov, recorded the entire event in letters and urged the scientific community to take the phenomenon seriously. Unfortunately, that call would go largely unanswered for nearly 200 years. The beginning of scientific investigation. In the 19th century, French physicist François Arago took a crucial step forward. He compiled the first systematic catalog of ball lightning observations, documenting more than 30 cases in detail, including their size, color, movement, and effects. He noticed a curious pattern. Ball lightning seemed more likely to appear near metal objects and sources of water. But identifying patterns was one thing. Understanding what ball lightning actually was remained another matter entirely. 10,000 witnesses. By the 20th century, reports of ball lightning were arriving from every corner of the globe. People with no connection to one another, living in different countries in different eras, described remarkably similar experiences. The objects share the same general appearance, behavior, and lifespan. By the end of the century, more than 10,000 documented sightings had been recorded worldwide. Yet there was a problem. 10,000 eyewitness reports. Not a single clear photograph. Not a single video that could be thoroughly analyzed. More than 200 theories. Over the last 150 years, physicists have proposed more than 200 explanations. The most widely accepted idea is the plasma hypothesis. According to this theory, ball lightning is a sphere of hot plasma, a state of matter in which atoms have been stripped of their electrons. Lightning naturally produces plasma. The problem is that ordinary plasma survives for only milliseconds before dispersing. Ball lightning can remain visible for seconds, tens of seconds, or even several minutes. Maintaining such a stable spherical structure would require a continuous energy source. But where does that energy come from? No one knows. The breakthrough of 2012. In 2012, researchers in Lanzhou, China, accidentally recorded a ball lightning event while studying thunderstorms with spectroscopic equipment. After a normal lightning strike hit the ground, a glowing sphere roughly 5 meters in diameter slowly rose into the air. It traveled about 15 meters horizontally and remained visible for approximately 1.5 seconds. Spectral analysis revealed the presence of silicon, iron, and calcium. All of these elements originated from the soil. The observation appeared to support a model proposed by New Zealand chemist John Abrahamson, the silicon vapor model. According to Abrahamson's theory, lightning vaporizes silicon in the soil, producing tiny nanoparticles. As these particles slowly oxidize in the air, they release light and heat. It is an elegant explanation. It accounts for the color, size, and lifespan of many reported sightings. But it leaves 3 major questions unanswered. Why does ball lightning appear inside buildings, aircraft, and submarines? How can it pass through glass? And why does it sometimes appear when no lightning is present at all? The microwave hypothesis. In 1988, Japanese physicist Ogam proposed a different explanation. He suggested that thunderclouds might generate powerful microwave fields capable of trapping plasma into a stable spherical form. Microwaves can penetrate walls, which could explain how ball lightning enters buildings. But there is one major problem. No one has ever detected such microwave fields near thunderstorms. Tesla's lost experiment. One name inevitably enters the discussion: Nikola Tesla. In 1904, Tesla claimed that he had successfully created ball lightning in his laboratory using high-frequency electrical discharges. Records of the experiment still exist. Yet no one has ever managed to reproduce his results. If Tesla truly succeeded, why was the method lost? To this day, nobody knows. Why can't we recreate it? In 2006, Brazilian researchers Paveo and Abdallah created glowing spheres by using electrical arcs on silicon wafers. The spheres remained suspended for up to 8 seconds. It was one of the closest laboratory reproductions of ball lightning ever achieved. Yet the spheres measured only a few centimeters across. They could not pass through walls. They did not follow people. And they did not explode. Other experiments produced rotating plasma balls or glowing ionized air, but none recreated all the reported characteristics simultaneously. Every laboratory experiment has managed to reproduce only one piece of the puzzle. Nature seems to accomplish what scientists cannot. The strange Soviet findings. In 1984, Soviet physicist Grigoriev analyzed more than 1,000 eyewitness reports. The results were astonishing. Nearly 1/3 of all sightings occurred without any thunderstorm activity. 7% involved spheres passing through closed windows. 12% of witnesses believed the objects appeared to respond to human movement. Most bizarre of all, roughly 2% of reports described spheres splitting into multiple objects and later merging back together. No mainstream theory can adequately explain such behavior. As if it were watching. In 1993, British physicist Stenhoff identified several unsettling patterns. Ball lightning seemed selective. It could pass harmlessly by one person while severely injuring another standing nearby. It appeared attracted to electrical wires and metal pipes. Sometimes it left perfectly smooth circular holes in glass. The glass was not shattered. It looked as though it had been melted through. Even more disturbing, many witnesses reported the same strange sensation. The sphere would stop in front of a person's face, hover there for several seconds, almost as if it were observing them. Then it would drift away. Many described the feeling as though something inside the sphere was staring back.